And problem number 2.7, that is from the Griffith, chapter 2, again from the particle in box. So it is, the particle is confined into infinite square well, and initial wave function that x0 is given. So what is given? That is ax and a capital A into small a minus x. And the range is also given. The first part of the wave function is between 0 to a by 2, and second part will be between a by 2 to a. So first is that you have to plot psi x0 and determine the constant. So obviously you have to normalize it, right? And then you have to go for psi xt. So here is the catch, okay? And what is the probability such that measurement of energy between E1? E1 means your ground state energy. So once you will write this one, you can easily calculate this one. And last one is very interesting. Find the average value of energy. Okay. So we have to solve each and everything. So let's try to see. And in this problem, what you will see? You will see how you can do the calculation in a very clean way. Are you getting my point or not? Otherwise, what will happen? You will just puzzle into the all this number. So let's try to go for all this calculation. Okay. So okay, so let's try to go for this one. What is my wave function? My wave function is psi x, and this value is equal to a x, and x is between 0 to a by 2 and a minus x, where x is between a by 2 to a, and you can assume 0 otherwise, because our wave function have to define from minus infinity to plus infinity. So first we have to find the value of a, and we will find it from the normalization constant. So how you will get it? You will just go for mod psi square dx from minus infinity to plus infinity must be equal to 1. But here you can just go for 0 to a by 2, and this value is equal to mod a square x square dx, plus you have mod a square, and you will go for a by 2 to a, and you have a minus x whole square dx is equal to 1. ठीक है, ये तो बहुत आसान है ना? फर्स्ट वाले में तो कोई कुछ करना ही नहीं. What will be this value? A square into this value is what? A cube upon 24. Okay. Now I can claim this integration will also a cube upon 24. Why? Because if you will plot this particular thing, this will be exactly symmetric about a by 2. The slope is exactly, this is positive, but this is negative slope. So this will be exactly symmetric about a by 2. Okay. But if you want to do it efficiently, what you can do? You can just put a minus x is equal to y, and this will be exactly same integration you will get. So this value is equal to also a cube by 24. And that value must be equal to 1. So what is value of a? So from there we can get the value of a square, and 2 into a cube by 24 is equal to 1. So a will be 12, sorry, mod a square is equal to 12 upon a cube. So this value is equal to 2 root 3 upon a cube 1 by 2. This is value of a. This is your value of a, and your wave function is something like this: psi x versus x. This value is equal to a by 2. This is a, and you can get this maximum value. Okay? So this is your first part. So first part we have done, and this will be your normalized wave function. And look at, this is linear in nature. Kaisa hai ye? Linear, proportional to x. Now next question is that, and this is given at t is equal to 0. So this is basically psi xt, psi x0. We have to go for psi xt. So how you will go for psi xt? So you will go for psi xt. That value is equal to nothing, but you have to write in a basis of energy eigen function. So that value is equal to Cn pi n e to the power minus I en t upon h cat, and n will be go from 1 to infinity. The whole challenge is how you will get this particular value Cn. So what is your Cn? Your Cn is nothing but phi n psi. And what is your phi n? Your phi n is equal to root 2 by a sine n pi x upon a. Obviously, it will be between 0 to a and infinity otherwise. So this is your phi n. Clear? So now the real challenge is how you are getting this particular calculation. So let us try to go for this particular calculation. If we are going into the functional form, then what is your Cn? Your Cn is equal to integration phi n psi dx, isn't it? And you have to go for 0 to a. This will be your Cn. So let's try to go for integration. And the actual challenge is how you are doing this particular integration. The concept is exactly same, whatever we have done, but this integration is really very nice integration. So let us try to go for this integration. So what we have to do, we have to calculate Cn, and that value is equal to 0 to a phi n psi x dx. And once we will go for this, we will divide this integration into 3 parts. The first part will be 0 to a by 2 x into 2 by a sine n pi x upon a dx. This is your first one. Second one is you will go for a by 2 to a. You have a into root 2 by a sine n pi x upon a dx. And third one is minus, you have to go for a by 2 to a x root under 2 by a sine n pi x upon a dx. So we have to go for these 3 integrations. Okay, so this is my integration 1, this is my integration 2, this is my integration 3. But the nature of integration 1 and nature of integration 2 is exactly same, only limit is going to change. So let us try to go for first integration. So we will just go for integration, we will put the limit after that. So what will be this one? This is x, and I will keep root 2 by a common. So we will just adjust it after that. And psi x, the normalization constant will also I will put later. Okay, so you can put the value of a also. Okay, you can put the value of a also. So a root 2 by a, I will put it later. Now you have to think how you can do the integration in a very smart way, in a very clean way. So how you will go for this? X sine n pi x upon a dx. What you will do? You will put n pi x by a is equal to t. So what is your value of x? X is equal to a upon n pi t. And what will be your value of dx? Dx is equal to a upon n pi t dt. Now once you will do this thing, then what will happen? Your integration will be very clean. And what will be limit? That will be, we will put it later. Okay, but before that, let us try to go for this. So what will happen? This integration is something a upon n square pi square, or a square will become outside, a square n square pi square, and this integration is t sine t dt. Look at this, is very simple, isn't it? And now you have to just go for this one. So you can just go for integration by parts. So when you will go for integration by part, you have a square n square pi square, and this value is equal to t minus cos t, isn't it? T minus cos t, sin t, integration of sin t is minus cos t, minus integration of minus cos t. You will just differentiate t and you will get this one. And what will be this value? The cos t will be sin t. So this integration is sin t minus t cos t. Now we can go for second integration. What will be your second integration? Second integration we will do it directly because this is not very tough. This one is, so now let's try to go for I1. What is I1? I1 is equal to 0 to a by 2 x sin n pi x upon a dx. That value is equal to sin t minus t cos t 0 to n pi by 2. So what will happen? Only this term will survive. This term will be 0, and obviously you have a square upon n square. Agreed? So from there we can easily write this value is equal to a square n square pi square, and that value is equal to what? Sin n pi by 2. ठीक है? Let us try to go for second integration. I2. What is second integration? The second integration is very easy. A by 2 to a sin n pi x upon a dx. So this value is equal to a upon n pi. ये होगा ना? This value is equal to what? Huh? What minus? हाँ अभी लिखेंगे minus. So a upon n pi minus cos n pi x upon a, है ना? And you will go from where to where? A by 2 to a. So what will be going to survive? So that value is equal to, you have a upon n pi, and then and one a is also there. So a यहाँ पर भी है. So this a is also there. So a square is there. So a square n pi, and what you will get? Cos n pi upon sub cos n pi with the minus. ठीक है? Third integration, I3. Look at how clean. Once I have done this one, then we can easily put it there. Third integration, a by 2 to a x sin n pi x upon a dx. That value is equal to, again you will go into this one. So you will just go for sin t minus t cos t, and that x is equal to, you will put here, x is equal to a by 2, then t is equal to n pi by 2. So that value is equal to n pi by 2 to n pi. Isn't it? So when you will go for this integration, what you will get? Sin n pi is 0. Isn't it? Sin n pi is 0. So what will survive? This one is going to survive. And cos n pi by 2 is also 0. So for first one, this one is survive. For second one, this one is going to survive. Isn't it? So क्या हो जाएगा जरा बताओ? Minus n pi cos n pi minus minus plus. So you have sin n pi by 2. Okay? And now you can see, this is very interesting. And साथ में क्या आ जा रहा है आपका? A square upon n square pi square. ठीक है? Now look at, यहीं पर हम सारा काम कर ले रहे हैं. What you will get? You will just have 1 integration 1 plus integration 2 minus integration 3. So what will happen? In the integration 1, this will be survived. From the integration 2 and integration 3, this term n pi is cancelled. और यहां पर माइनस माइनस क्या हो जाएगा? प्लस हो जाएगा. And this will be minus. यहां पर क्या है? This will be minus. So what will happen? This and this will cancel out. So what will your integration? Your integration is equal to a square n square pi square 2 times, because this sin term first वाला का क्या है? this sine term and this sine term will be survive. So that value is equal to sine n pi by 2. Look at this is your complete integration. Now कितना समय लग रहा है? If you will do it in a very nice way, then you can easily solve it. Isn't it? Now the most of the thing have been done. So what you have to do, and now we have to also put the value of a as well as root 2 by a. Okay, so once you will put the value of a and root 2 by a, then I have psi xt. What is your value of a? A की value क्या आई थी? What is that value? 12 upon a cube. So this will be 2 root 3, है ना? So this will be 2 root 3 and a to the power half into 2 by a root under, and you have a square upon pi square into 2 is also there, and inside this particular thing you have n square and pi n, and you have e to the power minus I en t upon, isn't it? And now you can see this a part will be cancel out.
Set the sign.
What? And sine term is also there. Yes. Sine n pi by 2 is also there. Okay? Sine n pi by 2 is also there. Now what is value of n is there? 1, 3, 5 is there. All other value will be 0 because sine pi by 2, sine 3 pi by 2 will be survive. 1 will be plus 1 and 1 will be minus 1. So we will just check it. What will be cancel out? So this thing will be cancel out. Isn't it? And this thing will be 4 root 6. This a will be cancel out by pi square summation over n is equal to 1, 3, 5, 1 upon n square, and you can just put sine here. That value is equal to sine n pi by 2, and you have pi n e to the power minus I en t upon h. So this will be your psi xt. Look at how you can solve it. Okay, so now what will be probability such that you will get particle into ground state? So for the n is equal to 1, so you have to just go for this mod square. So probability of getting E1 is equal to 4 root 6 upon pi square whole square. Isn't it? Because sine pi by 2 is 1. So this will be your probability. Kitna aa raha hai? That is 16 into 6 by pi square. You can, I think, 0.98 or something will be there. Next question is very interesting. Next question is, what will be average value of energy? So what will be average value of energy? The average value of energy is equal to summation over Pn into En. Okay, and into this particular Pn, what you will get? You will have 4 root 6 pi square whole square into summation over 1 upon n4. ठीक है ना? n4, and that value is equal to n square pi square h cut square upon 2m a square. n की value क्या हो जाएगी? 1, 3, 5 and so on. And from there we can get 16 into 6 upon pi to the power 4 into pi square h cut square upon 2 m a square, and here is summation over 1 upon n square. N is equal to 1, 3, 5 and so on. Isn't it? And once you will go for this one, so this value is equal to, so this is 16 into 6 upon pi to the power 4 pi square h cut square 2ma square, and this value is equal to 1 plus 1 by 9 plus 1 by 25. This is a very famous series. That value is equal to pi square by 8. That series is what? Pi square by 8. So you can remember this series. है ना? So this value is equal to 16 into 6 pi to the power 4 into pi square h cut square 2ma square, and you have pi square by 8 is the answer. Pi square, pi 4 is cancelled. 8, 2 is there, and 2, 3 is there. So you have average value of energy is equal to 6 h cut square upon m. Okay, so this will be your average value of energy. Now here we have going for the one particular method. The second method is that how you can get the average value of energy. You can just go for psi star h psi dx, that value from minus infinity to plus infinity. Just check how you are getting this one. So this is, maybe this is your homework, just how you are getting this one. Your average value must be come to this one. Hai na? So again, one more trick will be there. Are you getting my point? Why? Because in the h you have d square upon dx square. And once you will differentiate this one, x को 2 बार differentiate करोगे, you will get 0. So where is the catch? No. That is not about Fourier transformation. It will be very tough. Actually, there is a problem कि there is a step unit function को फिर से आप differentiate करोगे. So Dirac delta function will come into picture. So this is your homework. Just try to do this problem from this method.
अगर इसको Fourier transform करें,
तो Fourier transformation करोगे तो it will be lengthy, I think. e to the power I kx. Whatever you are saying, just try to do. Just try to do this. Okay. Whatever you are saying, just try to do this. Okay. So this is a wonderful problem, है ना? You have to do this problem at least twice, such that you can do calculation in a very nice way. ठीक है? So आज के लिए इतना ही रहने देते हैं. Next class में फिर देखते हैं.